Buildings waste 20 to 30% of their energy due to HVAC failures and equipment malfunctions. Traditional monitoring systems take 5 to 10 seconds to detect problems. Watch what happens when we use neuromorphic AI at the edge. This is a live working demonstration of the Smart Building Environmental Monitor. The system continuously analyzes 5 environmental sensors in real time: temperature, humidity, motion, carbon dioxide, and sound levels. Right now, all sensors are reporting normal conditions. Temperature is 22 degrees Celsius, humidity at 52%, CO2 at 580 parts per million. The system processes these readings every 30 seconds with neuromorphic efficiency. Let me show you what happens when an HVAC system fails. I'm simulating a temperature spike to 34.5 degrees. Watch the detection happen. Alert. HVAC failure detected in 42 milliseconds with 91% confidence. The system immediately recommends inspection. Now let's simulate a water leak. Humidity jumps to 88% with no occupancy detected. Alert. Potential water leak detected in 39 milliseconds with 87% confidence. The multi-sensor fusion is critical here. High humidity alone could just mean it's raining outside, but high humidity with no motion and indoor location means probable leak. Here's poor ventilation. CO2 rises to 1350 parts per million with occupancy detected. Alert. Poor ventilation detected in 44 milliseconds with 89% confidence. The system would trigger increased HVAC airflow automatically. The problem is clear. A single HVAC equipment failure costs $2,000 to $5,000 in repairs, plus downtime. Most failures happen because warning signs are missed by slow, expensive cloud-based monitoring systems. My solution uses neuromorphic computing at the edge. 5 environmental sensors processed locally by a spiking neural network. Instant detection with zero cloud dependency. No privacy concerns, no latency delays, no recurring cloud costs. For a typical 100,000 square foot office building, this system saves $14,000 annually by preventing HVAC failures, $8,000 from prevented water damage, $5,000 from reduced downtime, and $3,000 to $4,000 from energy efficiency improvements. That's over $30,000 in total annual benefits. With a system cost of just $500, this represents a 6,000% return on investment in the first year. The core innovation is neuromorphic computing using spiking neural networks. Unlike traditional neural networks that process continuously, SNNs only fire when events occur, making them 500 times more energy efficient. The architecture consists of 35 engineered features from 5 sensors, feeding into 20 neurons in the first layer, then 10 neurons in the second layer, and finally 2 output neurons for classification. This compact architecture with only 952 parameters achieves excellent efficiency at just 3.8 milliwatts power consumption. The model was trained using Edge Impulse with 10,129 real samples from the UCI room occupancy estimation dataset. It achieved 99.21% test accuracy and 98.1% validation accuracy. Perfect 100% accuracy on normal class detection, and 87.3% on anomaly detection. Compared to commercial building management systems like Honeywell, our solution is 100 times cheaper at $500 versus $50,000. It's 200 times faster with 42 millisecond latency versus 5 to 10 seconds. Power efficiency is 13,000 times better at 3.8 milliwatts versus 50 watts. and it uses advanced neuromorphic AI instead of simple rule-based logic. The model deploys to over 20 edge platforms including Arduino Nano 33 Sense, Raspberry Pi 4, ESP32, and STM32 microcontrollers. After int8 quantization, the final model uses only 15.2 kilobytes of flash memory and 1.4 kilobytes of RAM. Inference time is just 1 millisecond per prediction.